So earlier in this course, when we talked about the formation of our solar system, we called it the nebular theory. And basically, the majority of the mass formed our sun, and then we had a process called accretion that material came together and formed our inner terrestrial planets and our outer Jovian planets. But there was some leftover material, and they fall into categories like asteroids. They're rocky. Comets are kind of rocky, icy objects, and dwarf planets are objects that are large enough to be spherical, basically, but they're not large enough to be considered a planet. And as you probably know, Pluto is the most famous dwarf planet, I think anyway. So asteroids and comets and dwarf planets are all associated with our solar system, so they orbit the sun. They're in motion about the sun. And so asteroids actually, through the course of a night, will move, and so will comets, depending upon how the distance that they move in the nighttime sky kind of depends upon their relative position to us and all of that. But what you're looking at is a long exposure of the nighttime sky, and that streak actually is an asteroid moving across the sky. Now, we can see asteroids at night as pinpoints of light if they're at the right position to reflect the sun's light. So asteroids, kind of rocky leftover. There are a couple of large asteroids in the asteroid belt. The largest is Sirius. The second largest is an asteroid called Vesta. Okay. We'll talk about where these asteroids are coming up. Let's see, what else do we have? Generally speaking, there tend to be the smaller asteroids tend to be more in number than the larger asteroids. And you might think, well, let's just go ahead and take all the asteroids in our solar system and blob them together somehow, let gravity kick in or whatever, and make another planet. But actually, even if we did that, it still wouldn't be the mass of Mercury. So I debated, and I think I am going to go ahead and take you to several of NASA's websites in this chapter. They just do an awesome job. They're up to date, they're beautiful, they're creative. So there is a spacecraft called, I think the spacecraft is called Dawn. It's a mission to send spacecraft to the asteroid belt. And in the asteroid belt, I mentioned, there is Sirius and Vesta. And so here is a website, and I'll just kind of, tell you it's out there in case you want to take a look at it. And it's all about the mission, the Dawn mission, and it's just amazing stuff. As I understand it, Dawn has already visited Vesta and now is on its way to Sirius. So these are some photographs of asteroids, and the small asteroids, which remember there are more small asteroids than the large ones like Sirius and Vesta. The small asteroids are not spherical, they really look like potatoes. And remember that Mars has two moons, Phobos and Deimos, that orbit it, and to me they look like asteroids. They look like they're captured moons that orbit the planet Mars. So I wanted to go ahead and take you now back to, I believe it's Dawn's website, and to kind of point out, well, I guess not. This is just a picture of the asteroid Sirius and the asteroid Vesta. Both reside in what we call the asteroid belt, and I'm going to talk about where asteroids are. Most asteroids are between Mars and Jupiter. So, as I believe, Dawn is on its way to the asteroid Sirius. So, asteroids. Some asteroids even have their own little moon. So can you see this asteroid with its own little moon in orbit about it? Isn't that cute? It's just adorable. So this asteroid's name is Ida. And this moon that orbits the asteroid Ida is called Dactyl. It's just adorable. So I mentioned that most asteroids are found in the asteroid belt. So you may have heard of that before. So the asteroid belt is between the last terrestrial planet, Mars, and the first Jovian planet, Jupiter. We call those belt asteroids. Now there are two sets of Trojan asteroids that lie in the same orbit as Jupiter. And in fact, they orbit at the same speed as Jupiter. So I don't know if you can see them very well. Let me go ahead and bring up the circle this for you. Trojan asteroids are here, and there's a pack here. And they hang out at what we call stable Lagrange regions, ahead and behind the orbit of the planet Jupiter. So let's go ahead and show Jupiter orbiting the sun counterclockwise. So these go this way and these go this way. And here's the planet Jupiter. Those are called Trojan asteroids. And if I understand this correctly, actually the Earth has two sets of Trojan asteroids as well. Okay, so now this third type of asteroid are the types of asteroids that actually could go close to the Earth. Because you figure the belt asteroids, they're not going to intersect with the Earth. The Trojan asteroids, or in Jupiter's orbit, will not intersect with the Earth, nor will the Trojan asteroids in Earth's orbit intersect with the Earth. But Apollo asteroids are kind of wild hair, random asteroids. Okay. NASA is our how do you say, the United States organization that's keeping its eyes on things like, what do I want to say, asteroids that may potentially come close to the Earth. So that's what this whole website is about. It's called Near Earth Object Program. And so it's got two tables. The first table is recent close approaches. And so you can see where these are past dates. Today is actually October 13th, 2012. And the next couple of columns after the date, this column is how close is the object in astronomical units. Now, astronomical units is the average distance between the Earth and the Sun. I really like this next column here, the average distance, or it's the distance of the object in lunar distances. So lunar distance is the average distance between the Earth and the Moon. So, for instance, check this out. This object right here came within 0.2 lunar distances, so it's like closer than the Moon to us, right? The next couple of columns, the next column is what is the size or diameter of the object, and I believe magnitude is how bright it is. I need to look that up. And then how fast is it going? Okay, so that table is close approaches that happened, and this table are things to look forward to, upcoming close approaches. So don't show this to your kids. I kind of tease. But again, if you just focus on the lunar distances, we don't have one that's, and I think that one was in the news recently. We don't have one that's 0.2. Near Earth objects, it varies, as I understand it, with regard to how much advance notice we have. So I don't know. I just think that's interesting. And again, these would be the Apollo asteroids. All right. So one of the places, remember, where most of the asteroids are is a region called the Asteroid Belt. And the Asteroid Belt is between the planet Mars and the planet Jupiter. And there, as it turns out, there are actually kind of gaps in their location. And this has to do with kind of a resonance situation between that Jupiter is making these gaps, basically. So speaking of Jupiter, actually, we're thinking, or the thought is that Jupiter is actually the reason for all of those asteroids between Mars and Jupiter, and the fact that that material could not come together and form a planet between Mars and Jupiter, because the size of Jupiter kind of kept sending out kind of gravity waves, if you want to think of it that way. So Jupiter's the cause of the asteroid belt.